welcome to this handy Houdini tips video. So in this one, we're kind of continuing from where we left off in the orientation attributes one, and this is all based on instancing. So in this part, we're looking at instancing and more specifically terrain instancing. So we're looking at how to instance trees to get a kind of natural look. Now I'm using this as an example, but this kind of does go over other types of instancing. You're going to be using the same attributes, but I'm going to show you some techniques for generating variation and making it interesting. And then we're going to take it into Solaris and I'll show you how to use the instancer there. Now, do keep in mind that this does work in other renderers. So if you're not going to be using Karma, you can use something like Redshift. The only thing that changes is at the end, how you're actually going to instance. So you'll use something like s@instance or s@instance file as an attribute, and that defines what will be instanced into the scene. In our case, we're just going to be doing it at the Solaris level. So we're going to be using an instancer and a SOP import node. So let's get straight into it in Houdini. Let's go ahead and I'll show you what I have set up already. So to start with, I have a terrain. And this terrain is fairly straightforward. It's just a bunch of height field nodes, and then we have a little section where I mask, and the masking is actually important. So that's what I'm going to be showing you quickly. The rest of it is just kind of generic terrain stuff. So over here, we have a mask by feature, and this is the important part. So over here, we're masking by height and by slope. So when we do this, we're saying, okay, anything below a certain height, we're going to exclude from the mask, and anything that's too steep, we're going to exclude from the mask. That allows us to ensure that our trees don't go below our water level when we copy them to the points, because we're going to be using this mask to drive how our points are scattered. So again, we don't want them appearing below the water level, and we don't want them appearing on steep surfaces. So over here, it's just a copy layer that converts it from a mask to a tree layer, and then we clear the mask. Once this gets converted to geometry, you'll notice that the attribute stays on as an attribute called trees. We can use that to actually then instance. Now, if you didn't do it this way, so if you have a ready-made piece of geometry, what you can use is the mask by feature node. That will allow you to generate all sorts of sloping and angles and height things just based on feature, and you can do it after it's been converted to a geometry. So even if you don't have access to the height field, you still have access to the mask by feature node. If we go up a level, we also have this tree, just a basic tree. All system tree rotated 90 degrees on the x-axis so that it copies to the correct orientation when we use the instancer. Finally, at the stage level, so this is our Solaris or LOPS level, we're just bringing in that terrain and we're applying some materials to it. I've created some materials. These are Material X shaders. Don't worry about that too much in this part because we are going to be going over Material X shading and Karma rendering in a future Houdini tips video. So for now, we're focusing on instancing. We've got a camera and an HDRI, and we have our terrain set up with its materials. So back on the object level, we can begin to create our instancing points. Let's go ahead and create a geometry node and just call this instancing points. Inside of here, what you would generally want to do is bring in your terrain or whatever object you need to scatter onto. So we're going to bring in our terrain over here, and we're going to be using a scatter and align node. So this was used in that other video, in the orientation attributes video, and we're going to be using it again. Now, before we plug our terrain into this, let's set some things up. Because what's going to happen is when we bring that terrain in, it's going to scatter uniformly over everything, and that's going to be quite slow. So instead of doing that, we'll firstly define how many points we want. So I'm going to set this to 100,000. And then we're going to drive it by an attribute. So the density attribute that we're going to use is that trees attribute that we created earlier. We can then plug it in, scatter and align, and we should have some points being generated. Okay, so we have some points and they have orientation and p-scale and all of that, but we're going to be adjusting those values. For now, what we can do is we can use a copy to points. And over here, we're going to plug this into the second input. And then we're just going to create a basic UL system over here to the right. This UL system over here is just that. We're going to transform it up. So make it about the size of an actual tree. So we'll transform this up by about 5. Before we copy to points, let's just select some target points so that it doesn't have to run over everything. So right over here, just select a nice segment like this. And we can just copy to those points alone. So you'll already notice some issues. Firstly, p-scale kind of freaks out sometimes with this scatter and align node, because you'll notice that sometimes if there's a single point that's not surrounded by other points, it doesn't get scaled down correctly. So what you end up with is like one giant tree, like this one over here. So we're going to be doing this our own way. And so let's begin. This is actually where we're going to be starting on creating organic looking structures for things like forests, right? So what we're going to use is a lot of attribute noises. Attribute noise is your friend when it comes to generating variation. So we're going to plug this into our scatter and align. And over here, by default, it will be running over color. So we're going to adjust this. We're going to set this to p-scale. And we can plug this into our copy to points. So instead of our p-scale being an add operation, we're going to set. So we're going to use this to actually set the scale of our trees. Now, by default, the scaling of our noise pattern is going to be tiny. It's going to be at a 1 meter scale, so each tree will end up with a different scale. Instead, let's increase this element size to something like 50. Next, we're going to go back up to the enable remap ramp. What this allows is for us to control which areas have 0 values and which areas have 1 values. So we can actually bring up this bottom end and drop the middle. And what you'll start to notice is you end up with interesting patches of trees, right? So generally, try to avoid areas of like tiny trees. You still want them to be fairly scaled up. And then you can also try to avoid areas of complete emptiness, right? So rather just have smaller trees in some sections. So as you can see, by using this, we're going from this, where it's fairly uniform, to this, where we have little clumps of trees. And so this is a pretty useful technique for kind of honing in nice sections of trees. And it's one of the ways that we're going to be generating some variation. One thing that you will notice is that your trees on certain sloping angles do point away from the surface. And that's not really how trees behave in real life. So in real life, trees, even on a sloped surface, tend to point directly up. What we can do is go to our scatter and align and work on the variation over there. So the first thing that we want to do is go to this alignment, and we want to blend the normal with Y. So what that's doing is it's saying, okay, here's our normal direction. Let's blend it towards the Y-axis so that we're pointing straight up. So all we have to do is adjust this amount. You can see when it's 0, it's facing towards the normal direction, so it'll be perpendicular to the slope. If we increase it, it goes more towards 1, so more towards the Y-axis, and that's what we want. So we can push that up to something like 0.75, and we can give very slight random rotation around the cone angle, right? So around the normal direction, we can have slight variation. Additionally, another useful thing is to actually rotate our tree between 0 and 360. That's actually very nice to have, because what ends up happening is the same tree would appear different because you're viewing it from a different angle, right? So that's a useful thing to do. We'll just increase the rotation around normal. And just like that, you already have some decent variation. The next thing that you could do is something like a color variation. So what we can do is just another noise attribute. So we'll do attribute noise, plug it in over here. And this time we can change this over here to a float. And we're going to change the attribute name to noise. I like to just use an attribute called noise because it lets me know what it does, right? It's just a noise attribute that I can then use later on to drive other things. You can visualize it if you want, so you can activate the visualizer over there. Just ensure that the visualizer for your viewport is also on. Next, let's go ahead and set the operation to set. And again, we're going to increase our element size to something like 50. Now we want to offset this so it doesn't match our p-scale variation. And just like that, we have some color variation. Now we can go ahead and drop a color node, because this isn't actual color, this is just a visualization. So in this color node, what we can do is we can ramp from attribute, and over here, we can drive it by noise, right? So in here, we can then put some color attributes. So we can just do some dark greens and some desaturated yellow color. And just like this, you generate some variation in your trees. So as you can see, when you copy to points, you now have sections like this, right? You have a lot more variation and it starts to look a lot more interesting. And again, you can actually make changes to this with the remap range, right? You can have more areas being in the 0 range, or more areas being in the 1 range, or you can just vary it and drop areas in the middle, right? So just like that, we can start to get some interesting variation in our tree color. And perhaps this is a bit much, but something like that works quite nicely. So if we wanted to actually instance some trees to these points, what we would need to do is drop a null. And this null over here will just be our instancing points. So over here, we just have instancing points. So this is all of our points, right? And if we go ahead, we can go to our stage level. So at our stage level, let's just go ahead and switch to our Solaris desktop. That will give us access to all of this information over here in our scene graph. And that's going to be useful for when we instance. So we can go ahead and drop an instancer node. And with this instancer node, we can define how to bring in our points. So the first thing we're going to do is just set this as tree underscore instance for the primitive path. What that'll do is just give us a path that's easy to reference. We just know that it's now / tree instance, and that's all of our trees being instanced. So the next thing that we're going to do is not target an internal sub, but an external sub. The points that we need to fetch are those instance points. So we go ahead and choose our instancing points. And then down here, we're going to be needing to choose some prototype primitives. All that means is that we need to bring in a primitive or a geometry into our second input, and that's going to get instanced. So we can use a sub import node to go ahead and bring in our tree. So let's just minimize this, bring in our tree, and as you can see, it gets brought in over here. Again, we're going to adjust the path prefix to / tree. So we know that this is a tree and this is our tree instances. So we can plug this into the second input of our instancer, and you won't notice anything initially, but that's because you need to define how this is being instanced. So we can, by default, use the entire stage as a prototype. And what that does is everything being brought into the second input will be used to instance. So if we zoom in, we will now see our trees. They are being brought in as bounding boxes because when we instance, we need an easy way for the viewport to handle it. And so what it does is anything out of a particular range gets converted to a bounding box. Everything else is shown as geometry. Currently, our trees are tiny. So we're going to go up a level to our tree geometry, and we're going to increase its uniform scale to 5. So remember, this uniform scale gets multiplied by our p scale. So a scale of 5 would be a 5-meter tree, and then we scale it down based on our p scale. So if we have 0.5, that would be a 2.5-meter tree. So we're also going to remove this 90-degree rotation because of the way that we instanced. Remember, in the orientation attributes video that we did, we went over the fact that scatter and align aligns to the y-axis. So if our tree is facing the correct way, it will come in correctly oriented. It doesn't have to be pre-rotated before we instance it. So let's go back to our stage level and see what we have. There we go. So now we have some trees and they're all correctly scaled and correctly oriented. So what we can do is we can bring that into our merge node over here and merge it in with our terrain. If we go over here and take a look at the render of this, you'll begin to see what we have. There we go. So as you can see, all of our trees are being instanced into our scene over here, and they have all of their color variation. They're oriented correctly and they're scaled correctly. Now this is all being instanced, so this is pretty light on RAM usage. And you can actually navigate through the scene and it'll be fine. You shouldn't have any issues with this. As you can see, I can just navigate through the scene and look at different sections of this. If you're using XPU, you can do the same thing. You might run into some issues with XPU where you do hit the wall for instancing. So you might run out of VRAM. In that case, just switch to CPU. That will use your RAM instead. So as you can see, this is just one layer of variation, right? We're just kind of working with p-scale and we're working with color. Now, that means that we still only have one type of tree. Now, a useful way to generate other types of trees and to have our instancing switch between the different types of trees is to actually define an index attribute. So at our object level with our instancing points, let's go ahead and actually add something that's a little bit different. So this over here is fairly straightforward, right? I think many people are familiar with this kind of workflow where you're adjusting p-scale and color and then allowing that to drive your instancing, because that is something you do with particles. It's something you do fairly often. However, this is going to be something that's a bit new. We're going to start with an attribute noise. So once we have our points that are being colored, we can go over here to our attribute noise. This is our new one. And again, we're going to just work on an attribute called noise. It's going to be a float, and again, we're going to set it. We don't want it to simply add to the previous noise that we created. We want it to overwrite it. So we have this noise over here. And again, we can just visualize it just like that. So once again, let's increase the element size to something like 50, adjusting the offset. And now I'm going to show you something that's useful to do. And we're going to split all of our trees or our scatter points into species, right? So this is an easy way to think about it, because when you do it like this, you can think of having bushes and trees and different things, and they all kind of clump together. In nature, you'll tend to find the same types of trees all kind of grouped together, and different species tend towards staying in the same areas. So what you can do with that is, with this noise attribute, we can go ahead and actually create a little bit of code that can define a species attribute for us. So we're going to start by creating an attribute called i@species. You can call it whatever you want. I just find that calling it species in this case makes it a bit more self-explanatory, right? So technically this is an index attribute. We're going to be using it as an index attribute. So i@index is a perfectly fine name. but I at species is, self-explanatory. In this case, we need to change it to an integer. So this is something that you don't see particularly often, but we're going to be casting to int by using this little int function. Inside of here, we're going to be using floor, and floor rounds down. So if you have a value that's 0.1, it'll round it to 0. If you have a value that's like 0.9, it also rounds to 0. Next, we're going to take that noise value that we have. So at noise, and we're going to multiply it by the number of species that we want. So we're going to create a channel float, or rather a channel integer, so chi. Give it a name, we can just call it num species. And then outside of this, we'll just close our brackets and add a semicolon. So if we let this go over here, we now have a generator for a number of species. Now it might not be obvious what this is doing, so let's switch off our visualization for a second and drop a color node. And over here, we're going to random from attribute, with species being our attribute to generate a random color from. So if we take a look at our geometry spreadsheet for a second, you'll notice that in our species attribute, we currently have 0 for everything, right? So we only have one type of species. And that's going to be the same if we have it at 0 or at 1, right? All of these values are just going to be the same because, again, we're rounding down. If we push this to 2, this is where it starts to get a bit interesting. So this code is pretty useful because what it's doing is it's clamping sections of our noise and creating different types of species from that. So if we keep pushing this up, you'll notice that we end up with loads of different types of species. And that's because our noise value has a wide range of values from 0 to 1. And if we take that 0 to 1 range and then multiply it by the number of species we want and then clamp it into individual whole numbers, we'll get sections, right? So that's what we're doing here. And so we can have separate types of species. And this is really useful for instancing. What we can then do is create another attribute wrangle. And I'll just call this something like splitter, right? So this is just going to be something that splits our species. We're just going to say if I at species, so that species attribute that we created, does not equal the channel integer that we're looking at. So we're going to create a channel integer. That's just going to be called species underscore index. Then do something. What we're going to do is remove the point. Just like that, 0, at ptnum. What we're saying is if our species attribute does not equal the channel integer that has been specified at the bottom, then remove the point, right? So this is going to solo out each species just like this, right? So if we only have one species, right, it will just not do anything. If we have multiple types, so like this, we have 4, we can use our splitter to define each one. And we could duplicate this over and use it however we need to use it. So we have 2 species, one is being split over here, we duplicate it over, the other is being split over here. And then we can have 2 nulls over here. This one can be species underscore 1. And then we can have species underscore 2. So this is a pretty useful way of generating different types of foliage. So this is the workflow that you want to use if you're going to be doing 2 separate instances. So if we go to our stage level over here, what you would have is a separate instance node over here with a different species being brought in. Alternatively, you can actually use that species attribute that we created as an index attribute, and I'll show you how to do that now. So if we go back to our object level, to our instancing points, over here, where we have our species being defined, we can actually just plug this into our instancing points on the left over here. So I'm just going to click and put it in over here. So now this is being brought into our instancer at the Solaris LOP level. So let's go up a level to our stage. And over here, we're going to change a few things on this. Firstly, we're no longer going to use the entire stage as a prototype. We're going to need something a bit more specific. So the prototype index is now going to be driven by an index attribute. The attribute that we're going to use is that species attribute. Right. Now, that's not going to do anything as is, because what we need to now do is define our prototype primitives. So those are the primitives being brought in, and we need to kind of figure out which index is which. So to do that, we need to create a collection. So let's firstly create another tree. So we have 2 species now, but we still only have 1 tree. So let's go ahead and create 2 types of trees. So we're going to create a null over here. This is going to be tree 1. Okay, so we have this tree 1. We can duplicate this over. This one over here will have tree 2. So we want these to look different. So tree 1 is this fairly tall, thin tree. We'll maybe make a shorter tree over here. So let's go ahead and decrease the number of generations. We'll just do something like 7. Increase its thickness. Decrease this random scale to a negative value. And that should be fine, right? We have 2 trees that are fairly distinct from each other. So hopefully we can now see the difference. So if we go back to our stage level, we now have two types of trees. We need to specify which one is which in the sub import. So let's go ahead and choose tree 1 over here, duplicate it over, and choose tree 2 for the other one. Okay, so we can plug these in one after the other. Now, something to know about Solaris is that we're going to need to work on our path prefix now. So if we bring this up over here, you'll see that we have tree, right? And when we place this other tree, it just gets overwritten. So it adds the one mesh to the other mesh, and that's not really what we want. Instead, we need to define a subpath. So we can do import path prefix /tree /tree underscore 1. And then for the other one, we can do /tree underscore 2. So now we have two trees, right? You can see they're kind of stacked on top of each other over there, but that's fine. What we're going to do now is a collection node. And a collection node takes everything above it and starts sorting it into collections. So in this case, we're going to create a collection called tree underscore collection. And the primitives that we're going to use are the ones that are being brought in. So we know that that's /tree, / and we have tree 1 and tree 2, but alternatively, we can just use a wildcard and use asterisk, and that will bring in all of the trees and put it into a single collection. So we're now saying take all of the trees that are coming in and put it into this tree collection. We're then taking that, putting it into our instancer, and on our instancer, we now need to define the collection to look at. So on our prototype primitives, we're going to use %, tree underscore collection. So once you've done that, it'll now work. You'll now have two types of trees being brought in over here. And as you can see, we have sections where we're having those little low detail, small trees, and we're having areas with these bigger trees over here. And in fact, if we merge it and do a quick comma render, we should see the color difference as well. So remember, we separated these species and gave them two different colors. So you can now see that by doing our collection over here with the two trees and then instancing it based on our species, we now have two different types of trees, right? We have sections of different trees, and you can do this with a whole bunch of trees. You could create as many species as you want, use an index attribute, and then define it using this index attribute species, right? That index attribute can be called whatever you want. It's not like pscale and cd, where those are actually picked up by the instancer. This index attribute is user defined. So once we have something like that, we get a lot more variation going on in our scene. So just a quick overview of what we did here. We import our one tree, we put it into a path prefix of /tree, and then we put it into a subfolder of /tree1. We do the same thing with tree 2, and then we put them into a collection where we say all of the things that are contained inside of /tree, add them to this collection called tree collection. So we could do the same thing with a rock collection. We could do the same thing with a flower collection. So we can have multiple of these for each type of instancing that we need to do. Then on the instancer itself, all we're saying is fetch these points over here from an external sub. We're fetching our instancing points. Then we're saying the prototype primitives to look at are % tree collection. This is a pretty unique syntax to Solaris. I actually don't know anywhere else where you use it. But yeah, we're using % tree collection. So we're saying look inside of tree collection. Everything that you find in tree collection, we're going to be using over here. And then we say the prototype index is going to be an index attribute, and the index attribute to look at is species, right? That attribute that we created on our points. So then all of our trees get instanced to the different species that we have. And yeah, there we have it, right? We have it being instanced to our terrain. So yeah, that's just some useful stuff to know for instancing. In fact, this is basically all you need to know. Right, so all you would do from here is generate loads of different types of instances, and you would vary them based on the different features of your terrain. So if you have a sloping area, perhaps you want certain types of plants growing there. Low-lying areas will have different trees, and you would split them up into sections. You'd have this clumping based on your p-scale. You would have the color variation. You'd have the different species. And when you start layering your variation like that, you get really good looking terrains. So this is exactly the workflow that I would use for actual projects. So we actually worked on a project with Xiaomi, and I'll show you the mountains that we had to create. We had to create the Guilin Mountains. And for that, we use techniques like this, right? You're just scattering different types of trees, and it ends up looking pretty good. So here's some renders. I'll bring it up now. You can just take a look at that. But yeah, I'd suggest playing around with some instancing. It doesn't have to be trees or terrain or whatever it is. You can just scatter onto a grid and play around with the type of instancing that you're getting and just see what kind of interesting things you can get. So in the next part, we're probably going to be looking at a pretty advanced concept, which is going to be animated instances of geometry inside of Solaris. So that's a bit of a thing where we're going to be using variants and a bit of a more in-depth USD workflow. It's also going to be using indexing, but in a very different way. So that'll be coming up soon. If you like this video, I do hope that you leave a like. If you really like this video, feel free to hit the join button. If you really didn't like this video, you can leave a mean comment and dislike. It's up to you. But thanks for watching. I'll see you next time.